All right, we're going to pick up with question number 10. Number 10 is showing us a table. It says that the table below states the population of a certain country in millions. So we're looking at the years 1900, 1910, 1920. It's going up by 10 years each time we go down the table. So we go up to 2010. The population in 1900 is 75 million because we're stating it in millions. All right, so let's open up Desmos and we're going to put in our X values first. But if you notice, we're only taking those last two digits in the year because it says start with 1900 and let that be 0. So there's a lot that you're going to have to interpret in this word problem, putting it into Desmos. Okay, I have the years put in for the X values starting with 1900. We're going to make that be 0. We're going to go up 10 years every time we step down on this table. So we go from 0, 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. This is going to be the year 2000. From 1900, 100 years later, that's year 2000, and then 2010. Okay, our Y values we entered in from our chart that matched with the X values. So you can see if you adjust your graph, the points plotted here. Now we're going to hold down this dot, hold it down, and then we can turn on lines and we can turn on, there's a regression button that I've already hit. And then let me turn those lines off. Let's just put the dots up. Okay, so those are the points that we plotted. I turned on my linear regression. Let me put that back on. So here's the line of best fit. And here's the equation. So we're asked to write the equation rounding to the nearest 2 decimal places, or the nearest 100. So we can take that equation, y equals 2.12. The 8 is going to bring that up to 2.13. X plus 62.19. The 2 is not going to change the 9. Okay, the correlation coefficient here we see is close to 1. That means that there is a close correlation between the years and the population, and it's a linear regression. All right, so for 11 through 19, we have multiple choice. I'm going to go over this quickly. We want to find any vertical asymptotes, poles, and horizontal asymptotes for f of x equals x plus 3 over x squared plus 7x plus 12. Okay. All right, so we're going to factor the numerator and the denominator. The numerator is already factored into x plus 3. When we factor the denominator, I'm going to take, I brought this down here, x squared plus 7x plus 12. The coefficient here is 1, so I'm going to factor the constant into two numbers, two whole numbers. 1 times 12 is 12, 2 times 6 is 12, 3 times 4 is 12. I'm going to find a pair, if there is one, that add to that middle coefficient. 3 plus 4 is 7, so this factors into x plus 3 times x plus 4. So set that equal to 0. Set each of these factors equal to 0 and solve. So if you set x plus 3 equal to 0, subtract 3 from both sides, x is equal to negative 3. If you set the second factor equal to 0, subtract 4 from both sides, x is equal to negative 4. Okay, but if you look up here, when we factored, the numerator is already factored the denominator, this x plus 3 over x plus 3 is 1, so that cancels. So all we have to look at for possible 0 in the denominator is x plus 4. So set x plus 4 equal to 0. So when x is equal to negative 4, we have a vertical goes up and down, asymptote. So this is not vertical asymptote at y equals negative 4. It's a vertical asymptote at not x equals negative 3, because we crossed that out, at x equals negative 4. All right, so we've got the vertical asymptote. The whole comes from looking at what you crossed out, any common factors. So we crossed out x plus 3. So if I set that equal to 0 and solve for x, we get x equals negative 3. So we have a whole at x equals -3. And if we have a horizontal asymptote, we're going to look at the powers in the numerator and the powers in the denominator. The highest power is x to the first power, so we're going to write 1. And then in the denominator, we have a quadratic, so we have a squared term. We're going to write 2. If the numerator is smaller than the denominator, which it is, our horizontal asymptote is the x-axis at y equals 0. So we have a horizontal asymptote here. This is the answer for question 11. Oh, for the next question, we're going to look at this graph, and we're going to find the correlation coefficient. So that means I need to make a table. So how do I make a table out of points? I'm going to start making an XY chart. I'm going to start with the lowest point, so that my lowest coordinate is 1, -8. X is 1, Y is -8. So we're going to go across to 2, -7, 3, -5, 4, -3, 5, -3, 6, -2.5, and 8, -0.25. All right, now I'm going to put those into Desmos, and then we'll find our correlation coefficient by hitting that regression line and then seeing what it's closest to. 1, -0.93, -0.93, or -1. All right, I took those values that I wrote on my table, on my XY chart, put them into a table. So I'm going to hold this button down, and then I'm going to add the regression. Okay, I might have to zoom in, zoom out to see those points. They're way down here at the bottom. Okay, and there's my line of best fit. And my R value, that's the correlation coefficient, is 0.9705. So this is actually closest to 1, meaning there's a strong correlation there. So the answer is going to be A. All right, so it's closer to 1 than 0.93, and it is not negative. All right, now we're going to move on to question number 13. Make sure that we can see the question here. All right, which statement best describes the function graph below? It's continuous. It's not continuous at x equals 1. It's not continuous at x equals 2. It is not continuous at x equals 3. So I'm going to start on the left. Continuous means that if I put my pencil down and I try to follow this line right here, that if I can follow that line without picking my pencil up, it's continuous. So I'm okay until I get here. And then we have an opening at, let me go down, at x equals -3. I'm sorry, x equals +3. +3 is right here. So it's not continuous at x equals 3 because it jumps up. Now I've got to pick my pencil up and then continue up here. Okay, now let's move down to question number 14. We want to identify the coordinate pair for f of 0. If f of x equals, and we have the rules for each step, for these 3 steps in that function. So when f is 0, when x is 0, that means our input or our x value is 0. Let's see which rule we're going to use. So if x is less than or equal to -1, well, on the number line, here's 0, and here's -1. So less than or equal to, shade that in, and it would go to the left. So 0 is not included here. The second interval is from -1, and it's going to go to +5. So it's going to be an interval here from -1 to +5. So 0 does fit in that interval. So we're going to use this rule right here. So our Input is 0. We're going to put 0 in for x. So 3 times 0 plus 6. 3 times 0 is 0, plus 6 is 6. So when x is 0, y is 6. All right, so our answer is B. All right, number 15. We have f of x equals x squared minus 2x. And g of x equals, I'm going to highlight that in orange, equals x minus 3. What is f of g of x? So we're going to start inside, and we're going to look at g of x. That's x minus 3. So we're going to take all of that. Doesn't give us an input or a number for x. So that means take all of this and put it in to f wherever there's an x, that whole expression. So we're going to take x minus 3 and we're going to put it here. So x minus 3, and then we're going to square that, minus 2, and then we're going to replace x with x minus 3. Okay, and then we're going to simplify. So we've got to square x minus 3. So let me box that out. You could also FOIL it out, but I'm going to box it so you can see it. Got x minus 3 and x minus 3. Go down, x times x is x squared. Negative 3 times x is negative 3x. Negative 3 times x is negative 3x. Negative 3 times negative 3 is positive 9. Now let's combine like terms. We don't have any other squares. We've just got 1x squared here. We've got negative 3x and negative 3x. Add those together for negative 6x, and then plus 9. Okay, so this is going to be that first part, and then we're going to subtract 2, or let me just change that to plus and negative. So that's going to be plus negative 2x, and then a negative times a negative is a positive, plus 6. So now let's combine like terms. I only have 1x squared. So I'm going to write x squared. I have negative 6x plus negative 2x is negative 8x. And then 9 plus 6 is 15. So it looks like we have a match with D. All right, now we're going to go down to 16. Okay. Move this over. All right, we have f of x equals 3x squared minus 6, and g of x equals 2x plus 1. So let me highlight f of x and g of x so I can keep those separate. And then we want to find g of f of 4. So we're going to work inside out. So put that 4 into function f. Here's function f. So 3 times 4 squared minus 6. All right, we square this first. We get 16 times 3. And then we're going to subtract 6. 16 times 3 is 48. Minus 6 equals 42. Okay, so now that we have f of 4, we put 4 in, we got 42. We're going to take that and put it into g. So 42 right here for x. 2 times 42 plus 1. 2 times 42 is 84, plus 1 is 85. So our answer is B. All right, moving down to question number 17. All right, I'm going to graph this. I'm going to go ahead and graph this stepwise function, the 3 pieces, with the intervals. So I'll put the functions in separately, and then I'll put these in curly braces. Then we should see the graph, and we can identify our domain, which is our x's, and our range. So I have the 3 pieces of the step function put in with their intervals. So the first one is a linear function. So I'm looking at my x values. So it's going to start at -4. -4, and I'm going to go over to, okay, this one goes over, but it's not the farthest x point. So this one goes over, look at the x values, to 9. So from -4 to 9. So that is our domain. Now it is including, let's see if it's including -4. It's not including -4. We don't have that or equal sign. So we're going to have a soft bracket to the left of -4, but it is including 9 because it includes r equal to. So we're going to have a hard bracket around that. So look at your answer choices on your paper. And the only one that fits is going to be A. But I'm going to go ahead and check the rest of that. I'm looking at the range. The range is your y values. So it's going down to, it goes down almost to 12 before it becomes undefined, because it's open there, if you remember. So it's going to start at -12 being the lowest, okay, but it's going to be a soft bracket and it's going to go up to 0. Okay, look at your interval notation, and it does include 0, okay? So that's fitting right now. The range is -12 to 0. And then that second part is just all going to be 6. The y values are all 6 in that second step. And then the third step, the lowest value is 7. And then the highest value goes up, looking at the y values, to 23. You may have to zoom in a little bit to see that 23. All right, so the answer is A. I just went ahead and checked all of that. Let's look at number 18. Let's read the word problem first, and then we'll highlight the important information. At the local grocery store, apples can be purchased in a bag up to 5 pounds for a $3.49 a pound. But at the nearby bulk store, apples can be purchased in bags over 5 pounds for $2.99 a pound. Which of the following equation models the cost of apples? So we read through it to get an idea. Let's read back through it and highlight information. So if we go up to 5 pounds, can't go over, but it can be equal or under 5 pounds. The cost is $3.49 a pound. At the bulk store, over 5 pounds is $2.99 a pound. Okay, so let's model that. So up to 5 pounds, X is going to be less than or equal to 5 pounds because we can go all the way up, stay under. And then that's going to match with $3.49 a pound. So $3.49 if X is less than or equal to 5. So that matches with A. Okay, it doesn't match with B because this is greater than. So we're going to cross that out. We're going to cross out C because X has to stay under 5 pounds to be $3.49 a pound. It could be D, except this X right here is not supposed to be there. It's not $3.49 times X, it's just $3.49 a pound. Let me think about that though. I think I'm wrong. I think it's D. So if it's less than or equal to 5, it's $3.49 times X. So I think in class I might have said it was A, but it's going to be D because we've got to multiply whatever X is. If X is 1 pound, it's $3.49 times 1. If X is 2, $3.49 times 2. So the answer, I made a mistake earlier in saying it was A. It is going to be D. All right, which piecewise function is shown below? Now the way that I did this is I graphed it, but I'm just going to look at it and see if I can pick out which is which. I'm going to start with my domain. My interval here is going from roughly, it's -5, 6, 7, 8, 9, -9 to 5. So let's see, maybe it's further, it doesn't say, but maybe that's infinity. So X is less than -5. So I've got that here, here. It's not equal to because it's got an opening here. So I've got to cross out this one and this one. Okay? So it's between A and B. Now I'm going to start this interval at -5. So we're going to include -5. It has to include an equal to. And then x is between -5 and 0, not including 0. So that's going to be a check right here. Okay, it's colored in at -5, solid there. It's open at 0. And then we're going to go from 0, x greater than or equal to 0. So it's going to be B. You could do it this way by working through each interval, or you could graph each of these and find a match. All right, the last one, choose the statement which best describes the residual plot. So we plotted the tables. We made plots or graphs from the table, and we threw down the line of best fit. There are a couple of outliers here. We're not going to consider those. There is a linear regression here, a residual plot. This does represent a linear model. If it was more curved, it would be a quadratic model. That would be a nonlinear model. Does not indicate linear or nonlinear. It would just be dots all over the place with no correlation. Not enough data. It's not going to be that. This is more of a linear model. So if you have a regression line or threw down a line of best fit, it would be something like that. So the answer is A.